Alright, so this is the review. So for questions 1 through 12, it just asked us to factor. So here we're looking at the factor of 8x cubed plus 27. So first off, you should notice there are two terms and one of them is cubed. So automatically in my mind, I look for a sum or difference of cubes. So for this first one here, I'm going to take the cube root of this, and the cube root of 8 is 2. Cube root of x cubed is x. Then I'm going to take the cube root of 27. The cube root of 27 is 3. There's a plus sign. So it's going to be a, and it's going to be b. And then you just go through the formula, or you can use SOPs, but I square the first term. Opposite sign, product, so 3 times 2x is 6x, plus b squared, so 3 squared is 9. Alright, on to number 2. So number 2, same thing. I see a cube on both ends, and I see a minus sign, so the cube root of this is going to be y. The cube root of 64 is going to be 4, and we use that minus in the middle. So we're going to square the first term, opposite of the symbol, product, so y times 4 is 4y, plus sign, and then we square the last term, which is 16. Alright, for number 3, same thing here. We have the cube root of 64x cubed, which is going to be 4x, and then the cube root of 125, which is going to be 5, and then we have a plus sign in the middle. So we square the first term, opposite, product, so 4x times 5 is 20x, plus, and square the 5, which is 25. Alright, now we move on to the next ones. So here we notice there's a GCF between these three terms, so it is GCF is x, leaving me with x squared plus x minus 12. I'm going to do the x method, so that's going to factor out to x plus 4 and x minus 3, and let's not forget our GCF, and there's our answer. Alright, for this next one here, we see they both have a 2, they're both divisible by 2, they both have x squared in common, so x squared minus 16, this is a difference of two squares. So the square root of x squared is x, the square root of 16 is 4. We write that twice. One's positive and one is negative, and we make sure we can't factor any further, but we can't, so this is my final answer. Alright, for the next one, there's 4 terms. So whenever there's 4 terms, the first thing we attempt to do is factor by grouping. So I group the first 2, then I group the second 2. So I notice they have x squared in common, leaving me with x plus 6. The second one, they have positive 3 in common, again leaving me with x plus 6. So when I look at these two terms, they have x plus 6 in common, so we're going to factor that to the front. Open parentheses, now whatever's left on the outside goes in the second set, so we have x squared first, then we have a positive 3 second, so now I have x squared plus 3. This is completely factored because I can't go any further. Alright, on to number 7. So again, we have 4 terms, so we're going to attempt to factor by grouping. So the first set has x squared in common, leaving with x minus 1. The second set has nothing in common, so at least they have a positive 1 in common, leaving us again with x minus 1. So you'll notice they both have x minus 1 in common. And then what's left on the outside is x squared, and then a plus 1. I can't factor any further, so this is my final answer. Alright, for this one here, we're going to group the first 2 and the second 2, so we have x squared, which is going to be x plus 2, and then negative 4, we factor that out, leaving us with another x plus 2. Again, these are the same. And then x squared minus 4. Now x squared minus 4 is a difference of 2 squares, so if I were to factor this, it would become x plus 2, x minus 2. Now if you notice, there's another x plus 2 there, so we're just going to square this one to show that there's 2 of them. This one is just a difference of 2 squares. The square root of 25 is 5. The square root of x to the 4th is x squared. The square root of 36 is 6. And we're going to write that twice. One of them's positive and one is negative. Alright, on to the next one. 2x to the 4th and 22x squared, they're both divisible by 2, and they both have at least x squared in common, leaving me with x squared plus 11. There's nothing else I can do. There's no special cases, so this is completely factored. Alright, for this one, we're going to do the factoring x method, so I'll walk you through this one. You do the x method, negative 4 on the top, negative 21 on the bottom, and then divide by a, which is 1. So my factors that add to negative 4 and multiply to negative 21 are going to be 7 and 3, and the 7 will be negative. So we're going to write x minus 7 and x plus 3. Now if you look here, x times x is x squared, not x to the 4th. So a quick fix is you just square both of them. And now you'll see x squared times x squared is x to the 4th. And if you work it out, you will actually come up with this polynomial. And that's completely factored because I don't have any special cases or anything else I can do. This one, again, x method, 11, 30 divided by 1. 5 plus 6 is 11, 5 times 6 is 30, so c squared plus 5 times c squared plus 6, and that's completely factored there. Okay, no special cases, so that's it for that one. All right, on to number 13. The directions here do say to solve, so we're going to solve these. So first off, in order to solve these problems, we're going to set them equal to 0, so we're going to bring this 56 over by subtracting it. We're going to look for the GCF. They're all divisible by 2, x to the 3rd power. So x squared minus 3x minus, what's that, 28. Then we can do the x method to factor this. So x minus 7, x plus 4. Then what you want to do is set each one equal to 0 and work it out individually. So in my mind, I can divide this by 2. 0 divided by 2 is 0. The cube root of 0 is still 0. We add the 7 over, and this one we subtract the 4. And that's how we get our simple answers there. All right, for this next one, again, we're going to move the 22x cubed over. But again, recall, these are same terms. So we're going to subtract 22 from 34. So 34 minus 22 is going to be 12x cubed minus 48x. And now it is equal to 0. We see the GCF, they're both divisible by 12 and x. So we have x squared minus 4. So 12x, square root of that is x, square root of that is 2. And then we can set each one equal to 0. X equals 0, negative 2, and positive 2. All right, let's take a look at number 15 next. This one, we move it over. Again, we can combine the negative 8x squared with the 4x squared, negative 4x squared. So 2x cubed. When we add it, it becomes positive 4x squared minus 96x equals 0. Here we can factor out the GCF of 2x, so x squared plus 2x minus 48. When you do the x method, you get x plus 8, x minus 6. Again, you can set these each equal to 0, so we get 0, negative 8, and positive 6. All right, for number 16, this one, first we want to set it equal to 0. Now this one will be a little bit different because what you'll notice is when you try to factor by grouping, that doesn't actually work. So we're going to go straight to the rational root theorem. Step 1 is to find all the possible factors. So we have the constant term, which is 15, or you can write negative 15, doesn't matter on that part. And your leading coefficient is 3. So my factors of 15 are 1, 3, 5, and 15. My factors of the leading coefficient are 1 and 3. All right, from here, we're going to list all possible solutions. So we're going to divide 1 divided by 1 is 1, and if you put plus or minus, 3 divided by 1 is plus or minus 3, plus or minus 5, and plus or minus 15. Then we divide each term by 3. So 1 divided by 3 is a new one, plus or minus 1/3. 3 divided by 3 is plus or minus 1, but that one's already there, so we don't rewrite it. And then plus or minus 5/3, and 15 divided by 3 is 5, which is already given. So those are my possible solutions there. Step 2, we're going to go ahead and do synthetic division to see which one gives me a remainder of 0. So we have 3x cubed, negative 5x squared, negative 47x, minus 15. So this one, I know that one of the solutions when you work it out is going to be 5. So I drop the 3, we get 15, combined we get 10, multiply we get 50, combined we get 3, 15, and 0. So this right here shows that 5 is actually a solution to this polynomial here. All right, after this step, we're going to go ahead and do step 3, which is write the polynomial. So this is going to be our remainder, constant x and x squared. Step 4, we're going to factor it. So X method, 10 on the top, 3 times 3 is 9 on the bottom, divide by 3, 9 plus 1. So my factored form is going to be x plus 3 and 3x plus 1 because I can't reduce that. And last but not least, step 5 is my solution. So my first solution was this 5 here. If I set this equal to 0 and solve, it would be -3. And subtract the 1, divide by 3 is -1/3. And these are the several solutions. Alright, on to number 17. So for number 17, again, we're going to set it equal to 0. We're just going to remove that. We see there's a GCF. We can factor this using the x method. So x minus 5, x plus 1. And then we set each one equal to 0, so we get 0, 5, and -1. Alright, for this next one here, first off, it's missing a x squared, so it's like a factor by grouping, but I just don't have the x squared. And then when I try it, it doesn't work because there's no factors obviously there. So now we're going to do the rational root theorem. So constant and leading coefficient, we're going to identify those. So -48 and 1. So 1, 2, 3, 4, 6, 8, 4 times 12, 3 times 16, 2 times 24, and 1 times 48. And my leading coefficient is a factor of 1. So we're going to divide each one by 1. So plus or minus 1, plus or minus 2, 3, 4, 6, 8, 12, 16, 24, 48. So those are all my possible solutions. Step 2, we're going to do synthetic division. So we have 1x cubed, 0x squared, -28x, and -48. The answer choice you can choose to do on this one is going to be -2. So when you do that, it's going to work. So we drop the 1, we get -2, -2, -2 times -2 is positive 4. -24, multiply it, you get 48, which is 0. Step 3, we write our polynomial, which is going to be x squared minus 2x minus 24. Step 4 is we factor it, x minus 6, x plus 4. And then our solutions for step 5 are going to be x equals our one that we solved, which is -2. And then x minus 6 equals 0 is 6, x plus 4 equals 0 is -4. All right, and that's that for that one there. On to the back. All right, so for this one here, it says to what is the value of k such that x minus 7 is a factor of h of x equals 2x cubed minus 13x squared minus kx plus 105, just by our answer. So we just need to figure out what k is. First, we're going to take our pivot point, which would be 7 when we set it equals 0 and solve it. 3, 2, 1 constant, so 2, -13, -k, 105. And we're going to work it out. Drop the 2, 2 times 7 is 14, combine you get 1, you get 7, and I don't know what that is. But I do know the remainder has to be 0, because we're trying to prove it's a factor, and this would be -105. And 7 times what is -105? So I'm just going to use this calculator right here, and I'm going to, let's see, we're going to do -105 divided by 7, which is -15. Alright, now we can take this part right here and set it equal, so -k plus 7 equals -15, minus 7, -k equals -22, divided by -1, k equals 22. And that is the value you need to work this problem out correctly. Alright, for 20 and 21, it says determine whether the binomial is a factor of the polynomial function. If so, factor it completely. Okay, so we gotta, in order to prove that it's a factor, it has to turn to be 0. If it doesn't, then we stop there and it's not a factor. Okay, so the pivot point, x plus 9 equals 0, so that's going to be -9. We have 3, 2, 1 constant, so 2, 15, -23, and 36. So we just go through synthetic. Alright, and we see that it is, so our polynomial is going to be 2x squared minus 3x plus 4. If you did the x method, and we're just factoring it completely, we're factoring it, we're not solving it, right? So if I did the x method, so I'm actually going to do that right here, I get -3 divided by 2, and 2 times 4 is 8. So I'm looking at this here, and it doesn't appear that I can go any further than this, and I'm just going to verify that I did everything right. So x cubed, x squared, x constant, drop the 2. That's good. So that's good. X squared minus 3x plus 4. I'm just making sure. Yeah, it appears this is not factorable, so it's just going to be x plus 9 times 2x squared minus 3x plus 4. Because let's see if I can go any further than that. Alright, for this other one, pivot point, set it equal to 0, so we have 2. X to the 5th, x to the 4th, x to the 3rd, x squared, x, constant. So 5, 4, 3, 2, 1, constant. Alright, and let's go and do synthetic division. So that's going to be 12, 4, 8, 2, 4, 0, 0, 0, 0, 0. Again, our remainder is 0, so yes, this is. So we have remainder, constant, x, x squared, x cubed, x to the 4th. So we have, let's see, 6x to the 4th plus 4x squared plus, let's see, we can take out 2x here, or what is this, 2x, 4, this should be 3, and then x squared. Alright, now from here, what I'm going to do is I'm actually going to factor out the GCF. So the GCF from here is going to be 2x squared. So that's going to be 3x squared plus 2x plus 1. And originally we had this, don't forget this right here, this x minus 2. And this I'm going to try to do the x method to see if it factors. So we have 2 on the top, 3 times 1 is 3, divided by 3. So any factors that add to 2 but multiply to 3. And I think that's going to be impossible, so my completely factored part is this right here. Alright, on to 23, it says according to the rational root theorem, which is not a possible solution, right? So my constant term is 4, and my factors are 1, 2, and 4. And then my leading coefficient is 3, which is 1 and 3. 1 divided by 1 is 1. I don't have that here. 2 divided by 1 is 2. 4 divided by 1 is 4, so this answer exists. Do I have a negative 4? Nope. And then we keep going. 1 divided by 3 is plus or minus 1/3, which we have right here. And then 2 divided by 3 is plus or minus 2/3. And plus or minus 4/3 doesn't exist, so not a possible solution is going to be your letter C. Sorry about that. But your letter C is not a possible solution, because when you get your possible solutions, it's not a part of that set. Alright, and the last one is 24. It says to solve for x. And again, you can try factor by grouping, but the GCFs won't yield common factors in the parentheses. So we're going to go ahead and go through the rational root theorem. So step 1, we're going to identify the constant and the leading coefficient. So we have 75 and we have 2. So the factors of 75 are 1 and 75. And I'm just going to do this in a calculator real quick. So 75 divided by 3 is 25. We have 1, 3, 5. We have 15, 25, and 75. Alright, so those are the factors I came up with. And simply all I did was divide them in the calculator to make sure they worked. I don't think I saw any more than that. If you did, let me know. Factors of 2 are going to be 1 and 2. So now we just divide each one by 1. So 1, 3, 5. So plus or minus 1, plus or minus 3, plus or minus 5, plus or minus 15, plus or minus 25, plus or minus 75. Now we divide by 2. 1 divided by 2 is plus or minus 1/2. 3 divided by 2 is plus or minus 3/2. 5 divided by 2 is plus or minus 5/2. 15 divided by 2 is plus or minus 15/2. 25 divided by 2 is plus or minus 25 over 2. And plus or minus 75 over 2. Alright, step 2. We're going to find our synthetic division that gives us a remainder of 0. So let's see if we can do that here real quick. Let's see. Alright. So I kind of looked through this and I know 5 should work. So we have x cubed, x squared, x and our constant, so we're going to try 5 here, drop to 2, 10, 11, 55, negative 40 plus 55 is 15, 5 times 15 is 75, which is 0. Alright, so again, understand that this 5 is a part of your solution set. Okay, so from here, we're going to write our polynomial, so it's 2x squared plus 11x plus 15. Okay. So, step 4, we're going to factor it, so I'm going to put step 4 over here, so x method, we have 11 on the top, dividing by 2, and then 2 times 15 is 30. 5 plus 6 is 11, 5 times 6, so we have 2x plus 5. 6 divided by 2 is 3. So then our solutions for step 5 are going to be x equals, our first one was 5. Subtract 5 divided by 2, negative 5 halves, and then subtract 3, you get negative 3. Alright, and that concludes all the answers for the review.